This is the rear air conditioning unit on a 2015 Toyota Sienna, and I'm having problems. The front air conditioning is working just fine, but the rear air conditioning is not, and there's no videos on the internet about how to deal with the rear air conditioning of a Toyota Sienna, so I thought I'd make one. So first, I'm actually going to show you all the panels that you have to remove. Let me put them back on, and then I can kind of walk you through it. So these are the panels that you're going to have to remove. I removed this panel separate from this panel. I'm not at all sure that that is a good thing or not. So mostly they just have these clips like this on the back, and you can use a tool kind of like this to pop them out. It's not super convenient, but it works. The hardest part of this whole panel is right down here. This panel locks in underneath this scuff plate here, and there's these odd kind of shaped connectors, which basically is something the scuff plate is wedging something into here and here. So you got to pry the scuff plate up. I actually ended up using this tool in here to kind of pry it up. So you also have to take off the seat belt and disconnect it here as well as up here. And you just got to pop a whole bunch of clips. I'm not going to go through all the different clips. There similarly was a little bit of a clip under the scuff plate on the front end, but that wasn't nearly as tough. So you're going to take all of this off, and then you've got this upper panel here. There are clips that go into this part here. You need to pull off this weather stripping back here. That's the best way to do it. If you pull off this weather stripping, you can get at the clips. Here's a clip here, here, here. It's a little bit tough on here. You have to pull off these clips to pull this down, and then you can finally separate out this. It's got an unusual type of clip up there. So you're going to pull this plate out. And there's also a couple of vents here that I'm going to show you that I removed. Okay, so there's two vents. This vent here connects to the upper vents. You got to remove. There's actually a little cover that goes over this piece here, not just a simple clip. And then you just got to kind of wedge it out of there. This one here, you have to remove this clip here, and then it comes out fairly easily. All right, well, I'm going to try to walk you through this kind of in how the system actually operates. So from the front of the car, you have these two tubes here that are air conditioning. This is the cold, low pressure side here, and I think this would be the hot, high pressure side. I'm not 100% sure about that. Don't quote me. I'm not an auto mechanic. I've just been figuring this out. These two here are the hot water loop. So that as far as I can figure out, the hot water loop is always running. And I'm not going to say about the cold air conditioning loop because I haven't figured out my problem yet. So though all the heat and the air conditioning come back here, now what do we have? We have the fan here. There's a fan motor. Now in my case, the fan motor is working fine, so that's not an issue, but there is a motor controller here. You should also check your fuses if your fan isn't blowing. So the fan just sucks air in from, I believe, just this general vicinity here. I'm not 100% sure, but there doesn't seem to be any air inlet duct, so it's just taking the air that's from the area, which also makes it harder to diagnose the problem because the cold air that's coming from the front of the car is eventually getting circulated here, so it may seem that it's working, but in my case it actually wasn't working. Okay, so here's those hot water loops coming in here, and there's actually a small radiator in here. The air conditioning loops go into the back side, and then behind this block here, this is a evaporator. It's like a radiator except for cold. So this gets cold here. Also on the side, you can see here, this is a servo. This servo rotates, and I'm going to show you the operation, but it rotates like this, which then changes this right here, redirects air to either the hot through this heater core here, or down lower to go through the evaporator. And I think that's basically what this whole setup here does. On the back side here, look back there, there's this block in the way, but right back here is another servo motor. That servo motor actually moves a big frame that either blocks the top vents or blocks the floor vents or it moves it anywhere in between. So when you choose between floor and ceiling, that's what's actually happening. There's just this big white plate that shuttles back and forth here. Then let's take a look inside. Oh, before I look inside, I also want to point out, this is important. I'm going to zoom in here. Right here, this plug here, this is the evaporator temperature sensor. So there is a pinout I'll show you that you can test. You take your voltmeter right here, and you have to use two very fine tipped points. Okay, and then you can actually probe the contacts to tell what the resistance is, and depending on what the resistance is, you can find out whether that evaporator temperature sensor is working or not. So let me put that back in so I don't forget. Okay, let's stop and take a look inside the throat. Here's the pinout of that rear temperature, rear evaporator temperature. Note that the clip goes up in this diagram so you can help figure out which pin is which. And we're looking for pins 7 and 8 on this connector. So what you want to do is measure the temperature on the evaporator first. Let's say that it's 70 degrees. You should be seeing a resistance on a voltmeter between those two pins, 7 and 8, of 1.6 to 2.1 kiloohms. So if it's hotter than 68 degrees, you should actually see the resistance drop. And if it's working properly, it's going to be colder and you'll see a higher resistance. So you check first what the temperature on the evaporator core is, then second you check to see what the resistance of those two pins are, and it should match. So I'm going to move into the throat of the beast here. So as we look down into the throat, you see there's actually two separate plates here, or this top one here that the light's on, that is the radiator. That loop is always hot. It's going to be like 110, 120 degrees, but sometimes there's no air blowing over it. Down below here, this is the evaporator. So this is what's supposed to be cold. Unfortunately for me, what I'm finding is that under no circumstances does that evaporator ever get cold? And that is my problem. I'm still trying to figure out what the problem is, but I wanted to show you what it is. And so I've been using this infrared temperature thermometer on various surfaces here. And what I find is that this evaporator is not ever getting cold. It's always about air temperature. So that is a real problem I'm still trying to figure out. But that is what's supposed to happen. That's supposed to get like 50 degrees or something like that. Another place that you can use to diagnose what's going on with the air conditioning is you can actually pull back this insulation here, and you can feel this tube, the insulated one, should be cold. This one here should be hotter or hot. And on mine, unfortunately, it's almost reversed. So that is not a good sign. I'm not sure why the air conditioning isn't working there. Again, still trying to figure that out, but that is what's supposed to happen. Now, let me actually turn on the car, and I'll show you what happens when I adjust the temperature. So when I adjust the temperature, you're going to see this servo rotate back and forth. And that is going to cause this lever up here to rotate back and forth, causing air to either flow over the lower evaporator or the upper, sorry, you can't see that, the lower evaporator or the upper radiator. So let me turn on the engine and actually manipulate the controls so you can see that happening. Okay, engine's on, and watch this here and how this works as I change the temperature up and down. Okay, the engine is on, and now watch this here, and this, there's something here. Oh yeah, so there's a plate that actually comes down and shuts. As it comes forward, it actually shuts over the radiator, or sorry, the evaporator. And then this back here controls whether the air is coming through the evaporator or the radiator. Here we go. Okay, so it's 62 degrees. Now it's about 70 degrees outside. 67, 68, 69, 70, 71, 72, 73, 74, 75. So that's about halfway. Oh, it swung all the way, going all the way up to max. So right now, that's using the radiator and not the evaporator. I'm going to come back down, and that flap that covers the evaporator has just flipped open. So now the air is coming over the evaporator and not over the radiator. Let me go through that one more time. Raising the temperature. So now that's coming through the radiator, the heat, and now I'm going to come back down. So now that air is coming all the way through the evaporator. I'm going to go through this process again, and I'm going to show you what happens. By the way, this little white plate here, that is because it's partially set on floor and partially set on ceiling. I'll change that in a minute. But there's a plate underneath here that actually shuts off or opens up the radiator. So first, let me put it on maximum air through here, through the evaporator. Okay, changing the mode to be all face. So now that opens up the entirety of that there. Now I'm going to change it to be face and feet, so that's going to adjust it halfway. So now you get some face and some feet. And then finally I'm going to change it to be all feet, which is going to close off that back vent entirely. Okay, and then I'm going to change it back to all face. Okay, so I'm going to show you this is maximum air conditioning right now. I'm going to increase the temperature right around 69, 70 degrees now, 71, 72, 73, 74, 75. So as I go up in temperature, a plate comes over that evaporator. So now we're just getting heat instead. And let me go back down. So now it's opening up the maximum air conditioning, so it's all air conditioning. I'm going to go through it one more time. We're going to go to maximum heat. And finally, let's go back down to maximum cooling. The last piece of the puzzle I wanted to show you is a rear room temperature sensor. So this is obviously on the left-hand side back panel, and the manual says you actually have to pop off this panel, which would be an incredible pain. So all you have to do is just pop this thing right out of the wall right there. There is a cable on the back here. So you pull this cable out, you put your voltmeter against the two pins in here, and you can see whether it's sending the right resistance or not. And in my case, it is, which is good, but it's bad because I still haven't figured out what the heck's going on. Here's the pinout of that rear room temperature sensor. There's just two pins, so that's easy to find. Here's the pins on the air conditioning amplifier. Let me go down and show you. Let me scroll over this way. No, actually, we don't need to scroll at all. Here we go. So between those two pins, it's similar, except now you can actually force the temperature by blowing or cooling off that sensor. But let's say the ambient temperature is 77 degrees. You should see this 1.6 to 1.8 range. You breathe on that or gently heat it up. Don't use a flame. You get up to 95 or 100 degrees, you should see this lower resistance. And similarly, if you take some ice cubes or something and you blow some cold air on it, you should see much higher resistance. All right, I have one last thing to show you, and thanks to another YouTuber who showed me this, although his video wasn't perfect, it still allowed me to see it. So if I open that box there and I look in here, right back there, that is the thermostatic expansion valve, or TXV. This guy controls the expansion of the high pressure liquid into low pressure vapor. And if it's stuck closed, it is not going to let refrigerant through into the rear evaporator. And I think that is exactly what's happening here. And this other guy was able to show that he was able to remove it. Unfortunately, he didn't actually show the video of it, so it's still a little bit of a black box as to how you do that. I am not going to do that because it's going to require removal of all the refrigerant from the system, which I do not have the capability to do. I'm going to have to take it to a dealer in order to get that done. So, but the process that he did it was he removed the 2 screws here. He removed the pipe. I'm going to try to put this phone back here so you can see what it looks like underneath. Okay, so there's the 2 pipes. You can see it's held on by, I think he said it was a 4mm hex bolt. So there's 1 screw there, and then there's a plate, and behind the plate I think there's another 2 screws of some, or bolts of some type, holding it in. So in theory you should just be able to pull all of this out without having to disassemble the entire rear air conditioning assembly. But again, I'm not going to try that because of all the refrigerants involved. But if your system is already empty, you could do that. I would warn against and discourage against venting your refrigerant to the atmosphere. First of all, in practical terms, you have up to 200 psi in the system, and there's oil in the system. So you're going to be spraying super cold liquid or super hot liquid and oil everywhere. I think there's about 29 ounces of oil, refrigerant in the system. So that's a considerable amount of gas. Second thing is that in terms of global warming potential, even though these don't poke a hole in the atmosphere, turns out that these R134A, whereas carbon dioxide has a global warming potential of 1, R134A on a 20-year time frame has the global warming potential of about 8,000. So it's just incredibly damaging to global warming. So if you care at all about that, then as painful as it is to pay, it could be as much as $200 for them to drain, refill. I think it's worth it. So that's what's going on with the rear AC system. Hopefully you can use these tips to help diagnose what's going on. But unfortunately, in the end, I'm going to have to take it to a dealer for them to do it. But hopefully all of the steps that I've done to rule out the servos, to rule out the temperature sensors, to rule out the motors, hopefully that will save me some time and cost in the end. Before I put this panel back on, I thought I would show you guys the back side so you can see all the clips kind of in the order that I removed them. Okay, so from the back edge, the weather stripping is out here. You need to remove that weather stripping, and it's really easy to come in here, pop this clip, this clip, this clip, this clip, this clip. It's a little bit tricky up top. You can see there's a little slotted piece there. You just kind of got to pull that one out. Okay, here's a piece that fits into a slot. Here's a clip. Here's a clip. This upper piece does come out separately from the lower piece. You want to pull out this lower piece first because the lower piece sorry about that, but this lower piece clips into that upper piece here, 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 here. I tried separating the upper piece from the lower piece, and you actually can't do it. So these are actually riveted in here. I broke one of these before I realized that those are not coming out. Okay, so then on the bottom side here, you've got a clip. You have to remove the seat belt here. Clip on the front side here. Let me come around the other side. So you can see that there's a clip. The scuff guard actually seats into these 2 parts here. So you have to lift up that scuff guard. Okay, but from the weather stripping, you can access this clip here. There's another clip here that came out. I'm going to have to replace that. And then at the top edge, these just pop out 1, 2, 3, nothing where the sunscreen is, and then 1, 2 here. Oh, there's a couple clips, clip. So pretty straightforward. As a final note, this was the problem. This is the rear expansion valve. I don't know how it works. I couldn't figure out a way to test it really. I just know that it was stuck in the closed position. I think this is some sort of a thermostat here, and there's a pin that goes through here, and then there's a little valve down here that it's supposed to open and close based on the heat. In theory, if it's working, you should be able to run it under hot water and cold water, and it should open and close, but you can't actually see through it, and so that makes it challenging. All I know is that it didn't work. Now, guess how much it cost to replace this part? Even after I'd done all the diagnosis for them, it's still, they charged me a flat rate of about $900. So, moral of the story is, you know, there are certain things that could have gone wrong, which I could have fixed myself. It was a servo motor, I could have done that myself. But anything to do with the actual refrigerant, you're gonna have to at minimum take it to a shop to get them to drain it and refill it. And that was looking like it was going to be maybe $400. So I figured, oh, what's the difference? They're probably going to charge me about $600, but actually they ended up charging me $900. So that's what you have to know. Good luck on any problems with the rear air conditioner in your Sienna.